interact with all of you. So today, for the next 1 hour, we will be discussing about the application of a decision support system in water and nutrient management for improving the crop productivity in the changing climate. So actually, I planned the lecture in such a way that we will be covering these topics. However, it is being online. I request all of you to any questions, clarifications, or any doubts or something. Either you can put it in chat box, or you can ask the organizing team to stop me in between if needed, or else after the completion of the session, maybe we can interact for 5 to 10 minutes, depending on the time. So here what I wish to cover today is what is the scenario of agriculture and horticulture in India and how the climate change it is affecting, even though every one of us know the importance as well as its impact, because now it is in our doorstep. Everyone feels the change in climate. So there is no need or no history or no need to doubt about that, whether it is changing or not, because of the extreme events which we are facing, whether it is flood or drought or the extreme rainfall events, landslides, etc. Then with respect to agriculture, what are all the mitigations and adaptation options? And that actually, what are all the case studies, few case studies which we have carried out, I will be presenting, and what are the strategies and solutions, especially with respect to the decision support systems, which are commonly available, and most of them are free source softwares or whichever we have developed also I will be presenting. And these are all few such decision support systems, like one is NatMon, it is a nutrient monitoring, then DSAT, AquaCrop, CropWatt, Rinsey, ICNMS, like that. Few are there. If someone of you is interested in any of these software, because within 1 hour it will be very difficult to cover the entire thing, but they can be in touch with us for any clarifications or any doubt about this. So mostly this is funded by DST, TFAC, Department of Environment and Climate Change, Ministry of Water Resources, like that. So if you look at the horticulture scenario, most of the crops, vegetables as well as fruits and spices, everything, India stands in the top 5 ranks in the area as well as in the production, and which is having lot of export opportunities, by which India is earning a huge amount of means crores of rupees in the term when you compare with the agriculture sector. And the growth rate is also much higher in the case of horticulture crop than the food grains or the agriculture crops. But if you look at the scenario, whether it is a food grain production or even the horticulture production, currently we are self-sufficient thanks to all the agriculture researchers, extension team members, and the entire farmers. But still, we may feel short of our target. If you look at the future targets, as per the FAO, by 2050 we need to produce 450 million tons, and currently we are producing around 310 million tons for the last few years. So we need to produce almost 1.5 times higher than the current production. Whether is it possible to introduce new areas and all is really a question mark. So what we need is horizontal expansion will be much difficult, and some of the lands are going degraded and all. So you need to have a vertical expansion. At that juncture only we have the issue of climate change. So now it is a fact, and the science behind it is well established and well proven. And if you look at the data from 1880s or from pre-industrial era, it is almost 1 degree to 1.2 degree higher temperatures we are observing. But whatever may be the issues, but earlier and all, there were a lot of debates whether it is global warming or global cooling. Such kind of debates were there. But now it is extraordinarily clear that these issues are there at global level, regional level, as well as local level. But what you need to do, the strategies, whether IPCC or any government forums or any policymakers, now they are thinking that these local actions needs to be given more focus, so that the regional as well as global issues can be sorted out. Or we have a plan as per the AR6 report of IPCC. But if you look at the agriculture scenario, all of you may agree that agriculture has a significant impact because of the change in climate. It may be the loss in quantity, means in the sense loss in yield, loss in quality, then total, even including the cost of production, it has a direct thing. Then whether, if you look at that is one side, it is the negative impact caused by the climate change to agriculture. But similarly, there is another debate or another issue is that agriculture is also contributing for this emissions of GHG, which again further worsen the situation of climate change. So that is also, you need to control that. At the same time, we should not lose our production. So improving the resilience of agriculture system to climate change requires a protection of the natural resource bases and the development of new strategies, tools, and practices for adaptation. So if you look at the impact, it can be a short-term impact or it can be a long-term impact. So long-term changes, what we observe is so far in the climate change, it is the shift in the or the trend, whether it may be increasing trend or decreasing trend in rainfall, that is precipitation, then increase in the number of extreme events, means intensity of rainfall is increasing, which we are facing every year, especially if you see Kerala, last year also continuously there was a heavy rain, which results in floods as well as landslides. So recently also the same issue, if many of you might have read, in this year also in Wayanad, it has taken a lot of lives. So this is a common issue. Then coming to directly to agriculture, if you see, there is a direct impact on the crop yield as well as crop quality. So what we did is, this has to be substantially proven or scientifically proven how this is happening. So we did few case studies, that is only now I'll be presenting. So this is one of the study funded by TIFAC. TIFAC is nothing but the Technology Information Forecasting and Assessment Council of Government of India. In this, we, along with the Institute of Rural Management, then National Institute of Hydrology, these three partnering teams, as well as the ESA, that is the International Institute of Applied System Analysis, Austria, they are the policymakers or think tank of the FAO for deriving the food and agriculture related policies. So here what we did is, we used this model called agroecological zonation model, which has 5 modules. I will describe briefly about this. So it has a 5 module. First module is deals with the climatic analysis. Then the second module is about the biomass and yield. Third module is agroclimatic constraints, means with the data of climate as well as the crop production details, how the climate factors, if suppose it is changing, what will happen to the yield because of the climatic related constraints. Maybe it may be due to high temperature or very low temperature, heat waves, like that. Similarly, it is shortfall in rainfall, deficit in these things. Those things related to climatic parameters, or you can call it as weather parameters if you look at the seasonal level. Then the fourth module is the agroedaphic constraints, which is the soil related issues. It may be soil salinity, soil problem soils, or soil workability, especially the structure related issues. All those things are captured in the fourth module. And the fifth module is nothing but the production potential of each crop. Means once a variety is developed, it may have its own potential. If everything is good, for example, soil, climate, and all other environmental settings or environmental covariates are fine, then what is its ability to produce? So that is called the production potential of that potential crop yield. So this module will calculate all these things, and with the constraints, what is the actual yield we are getting and what is the potential yield. So this will give you the yield gap. In that yield gap, based on the spatial data sets of land resources, crop statistics, harvested area, and all, we can understand where the issues are happening, and in future, how, if the climate is changing, that means temperature is increasing, rainfall we cannot predict. So such a situation, what will happen to the crop? So yield can also be predicted. And based on that yield gap, which are all the strategies we can apply so that the yield gap can be reduced. So this is what all the module deals with. It's an open source software. You can see that it's a global agroecological zonation model. So in that module, after you understand that whether initially we will classify the land into 5 classes: very suitable, suitable, moderately suitable, marginally suitable, and not suitable. So after that, if you want to improve the yield or reduce the yield gap, what are the management strategies you can adopt? So for that also, we have developed 3 scenarios just for understanding: low level, medium level, then high level. Similarly, irrigation also, you can go for different options. We have tried flood irrigation, sprinkler irrigation, micro irrigation, drip irrigation, then drip fertigation with precision farming, then as such rainfed scenarios. So initially we have gone for the climatic analysis, and we found that you can see from this particular image that from this portion onwards, you can see after 1960s, there is a lot of change, especially this is a one sample data we are showing for Kerala. Almost we have done for 120 years. Particularly after 1960s, we can see that the frequency and intensity of the rainfall is changing. This dark red color indicates that. So which may be due to the fact of related to the climate change influenced by the anthropogenic changes. So here the historical data we have used around 110 years to 120 years data, because we started in 2010 to 20. So initially we have taken 1980 to 2010 as the historic period, and beyond that we have taken as a future scenario. But over the period of study, we completed the study by 2018. So almost up to 2018 we have taken as the historical period. And then initially we started with the IPCC 5 AR5 report, that is RCP scenarios. But later, once in 2022, when the new scenarios has come, we have updated with the SSP scenarios, especially SSP 1.9 to SSP 8.5. These are all, I hope many of the participants may be aware of this. If any one of you have some doubt, we can discuss this also. Like here, the SSP 8.5 is the worst scenario, which is similar to the RCP 8.5 also. And then we have gone with the different models, almost 30 models we have tested, and which one is matching to the Indian conditions, because this study area, as I mentioned in the beginning, we have done for 3 locations. One is Kerala, another one is Gujarat, whole of the state, and then Madhya Pradesh, Bundelkhand region. So these 3 regions, the long historical data we have collected from IMD, and based on that, whichever model is coming closer to that for the historical data, that model only we have taken. Even though we have taken all the 30 models, out of which then it's 4 GCMs, we have found that it is matching with the field realities at the ground. And then this individually also, this 4 is also not following. So what we did is ensampling of all these 4 models and mixed together, and then we have gone for the future scenarios. Future scenarios we have taken 2011 to 40, then that 41 to 70 and 71 to 100. So that is what the scenarios. Then produce the yield maps, suitability maps, all those things. This is just a sample I am showing for yield of rubber, rice, many crops, coffee. And we found that, just I am not going into the detail of each one of crops, but if you look at that, for most of the crops, we found that yield is declining wherever, but when you go for some management practices, especially in the case of rice, black pepper and arecanut showed an improvement in the yield. And some cases in coconut also, we found that if there is managed properly, we got a positive trend. Otherwise, if you generally look at, most of the crops are declining in yield in the future scenarios. Similar is the case with the site suitability also. For example, in the case of coffee, which is a very good example we have taken, and it's well appreciated also. I'll show that slides later. So currently the coffee growing area may not be suitable. Almost 80% of the coffee growing area may not be suitable in the future scenarios, which means that it is very sensitive to climate factors. So based on this, next currently now we are doing with under NICRA this project with along with the Indian Institute of Spices Research. So here we are considering 3 crops: turmeric, black pepper and ginger. So this is one of the paper from that. So turmeric importance, all of you may be knowing, and the main producing states as of now is Maharashtra, Telangana, Karnataka, Tamil Nadu, Madhya Pradesh, Andhra Pradesh, and Maharashtra. So here our main objective was to understand the terrain suitability based on the historic climate data, then identify new areas, whether any new areas can be brought under turmeric under the changing climatic scenario in the future. And third part is, in future, which are all the area will become hotspots where it cannot be grown or there is a change. The same methodology only we have adopted here also, agroecological zonation model. So I am not going into detail. These 4 modules, and the 5th module is suitability. and potentially. So here, compared to the earlier one, here we have increased the number of models. Since the selected crops are very specific to climate, especially the spices, very sensitive also. So we have gone with the different models and then did the site suitability analysis by AHP methods, weighted overlay analysis and different methods, and then compared with the field data as well as your observation data with the field experiments, which IASR was coordinating. So these are all the thematic maps. So if you see the area production productivity data from the statistics, similarly from the research database also, we have compared and we found that climatic factors, especially the temperature, maximum minimum temperature, are significantly influencing the turmeric yield. And using some machine learning models also, we have attempted that, and which month the temperature is more influencing, all those things we have identified, and then the same has been applied into these models for the future scenarios. So then we found that future scenarios, especially in the later part of the future scenarios, and that too under SSP worst scenario case 5.8.5, you found that many of the areas which is currently suitable is becoming not suitable. So which is very what you call threatening kind of thing. But if you look at the current scenario, it is somewhat better, and some new areas also we can identify. But when coming to the hotspots, we found that based on the analysis, with currently it is growing on the popular states, you can see the hotspots, especially the Gujarat region and some of the Odisha as well as the northern part of Karnataka. We can found this also we have done for different categories like temperature, rainfall, maximum temperature, minimum temperature, then rainfall, humidity, all those things individually how it is having, and when you combine these parameters, what is happening. So the results showed that you can see that this is the SSP2 scenario, SSP 8.5 scenario, and the result shows that new areas, there is a possibility that currently, as of now, you can explore new areas like Punjab, Haryana, Chhattisgarh, Gujarat, where you can expand the cultivation. Whereas the hotspots, now currently it is grown like Maharashtra, Gujarat, and Madhya Pradesh. Some of the areas will become hotspots, and in the worst case scenario, these areas we cannot grow, or even if you grow, it will be a lot of vulnerability issues, means yield reduction you will have to face. This we have confirmed with few field experiments at different locations also. Under elevated temperature, what will happen? Under precipitation changes, what will happen? Flooding, what will happen? Like that, a few studies we have done and confirmed that. These are all small field experiments, but for validating the model, we have used such kind of things. So now we have identified that these are all the issues with respect to the climate change. Yield decline will be there. Even if you manage with some of the strategies, how much yield improvement we can get. So that we have gone for few field studies. So these are all generally we have attempted both on soil and water nutrient management, which is possible for regulating that, because some of the natural parameters you cannot change it. Under controlled conditions only it is possible. Whereas in the open cultivation, what are all the possible changes we can try? That is what we have attempted. And these are all some of the techniques. One is improving irrigation efficiency through precision farming, micro irrigation, irrigation scheduling proper, and watershed management, then rainwater harvesting for especially the water scarce areas, then water quality management, and minimizing the water use. So there only we have applied these decision support systems, especially whichever I was discussing. Like NACMON, Global Agricultural Zonation, Hydrus, Cropwatch, Grunsi, Aquacrop, and Century. So this is one of the study carried out in Kerala as well as Tamil Nadu, where we promoted the drip fertigation, especially under precision farming techniques. And it is done through the farmer participatory approach. That is one of the advantage of this particular program. So just one example, I will be showing one of the case study which was funded by Department of Science and Technology with a fund of around 1.25 crores. And here we have done almost all the districts of Kerala. We have taken some few plots in each district and selected the major crops and gone with the irrigation scheduling, one thing, then fertigation schedule, like depending on the soil type, soil characteristics, as well as the crop requirement. And the schedule has been prepared using these models and given to the farmers, and farmers themselves were operating the drip irrigation system. Only technical advice was given to the farmers. So this is a list of the farmers. So here, as I mentioned, two things we have given. One is irrigation scheduling, means quantity of water requirement, as well as the intervals. Then the second one is related to the drip fertigation schedule. So in this case, you can see the soil wetting pattern for the banana plot. So initially we have collected the soil samples from that particular location, and then we have modeled it. So this is, you can see during the irrigation process, if suppose the farmer is irrigating for 2 hours, how the soil moisture pattern is there. This is 2 drippers for 1 banana. So after 24 hours, how the moisture will become, after 48 hours, after 4 days, like that we have simulated, and that has been verified in the field also using soil moisture probes and all. That has been the published paper which I was showing. So here in this particular case, up to 48 hours means up to 2 days, there is no need for irrigation. So likewise, for all the plots we have calculated and given to the farmers. So the farmer, actually what we will be giving is, you need to irrigate for 2 hours at the 3 days intervals, or 4 days intervals, or 2 days intervals, like that. Similarly for vegetable, this is another example for vegetable plot. Here they have to irrigate daily. So like that, that schedule at what time they have to operate, that has been given to them. And for their convenience or to understand, we have monitored these crops in their farm using soil moisture probes and all. These are all some of the photographs of those farms. You can see that. And that has been, you can see from here, this is monitored in the field itself. Similarly, for initially for developing the irrigation scheduling, we have brought the samples in the lab and analyzed for running the model. And then for validation, we have done in some selected plots how the soil moisture is behaving. So these are all some of the crops. So you can see that, for example, this case, you can see the uniformity in size of the produce. So that was one of the advantages, since water and nutrients are regulated. So what was the outcome? What we observed is 100% higher yield, which is the positive, because almost all the plots, I've shown here only the results of Kerala, but Tamil Nadu also the same has been done. So almost we got a extraordinarily high yield since water and nutrients are being controlled and given as per the requirement. The 90% first grade products, as I was telling, the uniformity in the produce also there. Then 30% premium price, 5 to 6 days shelf life was more than the normal product. And we observed that around 40% savings in water and 25% reduction in fertilizer usage. Then 30% energy saving, especially if you talk about greenhouse gas emissions and all. So electricity you can reduce, extended crop harvest, and empowerment of farmers. So this is one such technology by which some of these critical issues with respect to climate change we can manage to a greater extent. That is what just I was presenting. So is there any doubts or clarifications or questions to be asked? Maybe I'll take just a break. Any questions or being online, I'm not sure, that's why I stopped. And even you can put it in chat box also. If there is no more questions, then I will continue, and after the presentation we can.
So we will take question answers at the end.
Okay. Then I will continue. Yeah.
Please continue.
So, yeah. So first, I was talking about the drip fertigation, which is one of the technology or management with the help of decision support system, how we can manage. So now, next part I will be going is mainly for the rice crop. What are the soil and water management techniques, especially under the changing climate. So that this is one of the review paper which we have written, and if someone of you is interested, you can go through this paper. So this is based on whatever results we have done based on the what you call the impact of climate change, as well as the how to manage it. This is one of the project in which we tried to attempt the yield forecasting of paddy with the help of crop simulation model and remote sensing data, and what are the management strategies we can adopt. So here we have used satellite data, then ground truth data, crop cutting experiments, and crop yield at the Grama Panchayat level. That also we have measured, and then validating the same with whatever models we have attempted. So this was the methodology we have used for the rice area mapping. Normally rice is being cultivated during monsoon season, so there will be a lot of cloud coverage. So what we did is using high resolution satellite data, especially not only optical, we have utilized microwave also to understand or to map exactly where the paddy is there. So using the satellite data, we have done this project was done during 2019 to 23, those period, and we have validated the this remote sensing database based on some field experiments conducted at farmers field as well as in the experimental stations. So this is one of the experimental stations that in which we have this is mainly utilized for validating the crop simulation model. Especially we have attempted with the DSAT and EPSIM, as well as one more model. Infocrop also we have attempted, but the results whatever I am presenting is based on DSAT. So here the different treatments were also given even for upland cultivation under especially the aerobic rice. Under the changing scenario, if suppose the farmer there is a water scarcity is there, so if he is going for aerobic rice, what will happen? So like that, for different scenarios, we have attempted field experiments also, flooded condition, aerobic conditions, then DSR method, transplantation methods, the nutrient levels different. It is being put here. You can see that high, low, medium, like that. Then varieties also we have tested most of the popular varieties grown in Kerala as well as Tamil Nadu. And the measurements what we have done is morphological measurements, soil measurements related to moisture, then physiological measurements like photosynthesis, stomatal conductance, transpiration, etc. So this is one of the upland cultivation where we have gone for the aerobic rice. So including photosynthesis, all those parameters have been collected, and this is also published paper. So with this experiments, we have calibrated for rice, popular varieties in Kerala, Uma and Jodi. Similarly, with respect to Tamil Nadu, also some 4 varieties we have calibrated. Then coming to the field forecast, what we did is we have taken the spectral signatures from the remote sensing images as well as from the field data using spectroradiometer. This is one of the sample which we are using, spectroradiometer which we are using. So you can see from this image, the remote sensing. This is the remote sensing image. Actually, 1 pixel I am showing. So A, B, C, D is the different stages. Means starting from the initial stages, vegetative stages, tillering, flowering, and maturity stage. So you can see the color difference. The same has been observed in the spectroradiometer field observation as well as in the satellite imagery. Even though numerically the values were different, but the pattern or the trend we could observe. So this is what we have used it for calibrating and validating the models, and it was very well matching with the observed as well as the predicted yield. And in addition to that, we have gone for nutrient management as well as water management. Water management we have tried with the crop wort as well as aqua crop. Aqua crop is what here I am showing. So then the spectral data what we have collected in multiple fields, especially farmers fields also we have taken. These are all some of the field data from Wayanad. This is the published paper from that for the hyperspectral data. Then we have compared the spectra for different days, like 50 days, 60 days, 75 days, 85 days, like that for different varieties, so that the spectral signatures, whatever we have taken, was attempted to match with the remote sensing images. So here it is for the Alappuzha region. Then compared that, this is Palakkad. So like that for different fields as well as this is in the Agricultural University Research Station. Similarly, it has been done for Tamil Nadu also in 3 districts, especially Pudukkottai, Karur, and Tiruchirappalli district. So what we done is, based on this, we have predicted the yield. First one is area mapping. This is what we have done here. You can see that accuracy was around 89%. The yield variation was around. It is a very good one. If you look at the overall regional level prediction, we got up to 80% prediction, and then it has been aggregated to the Grama Panchayat level. So one advantage with this particular method is, during the crop season itself, we can identify where the crop is grown. And if the yield is forecasting, means predicting yield is less, so you can plan for some management practices by which you can improve the crop productivity. So which are all the area actually we are getting more yield, we can identify. Which are all the area less yield, we can identify. So we can target those less yield areas by implementing some management strategies in field season. Means during the crop growing season itself, we can manipulate, or we can modify the management practices and improve the yield. So this is one of the paper published from that. So this is another study which we carried out for Punjab and Haryana. So understanding the water stress, how it is there, at which area it is being stressed, and how it can be managed. So then similarly, based on the request from the Department of Agriculture for Kerala, we have done for some drought assessment studies also using the softwares. So this is one coffee which I was telling earlier. You can see this is a wet year, 2007 April and May, and this is a drought year. So this is based on NDVA only, but still you can understand these areas are severely affected. So which was evident from the coffee board yield data also, that also we have published actually. And then based on that, we tried to attempt to develop a decision support system. So for the drought assessment. So this is what for Palakkad region we have made it. So this is currently also running. You can verify from our website, drought information system. So like that, we have a few decision support system also based on the results, whatever we have obtained. And coming to the climate change, we cannot go without addressing the carbon related issues, especially the carbon sequestration as well as the GHG emissions. So for that also, what are all the decision support systems or tools available and how we can manage that. So here what we did is, especially this was funded by Ministry of Environment and Climate Change, and currently one project is going on with the NRC. So this is eddy covariance tower is the one which you can measure the CO2 flux, water flux, and all those fluxes, but it's a costly thing. So it may not be possible or feasible in all the locations. So what we did is, initially we gone with the change in SOC stocks based on the survey data as well as the field measurements. And for field level measurements, we have gone for, especially for carbon dioxide, we have gone with the alkali trap method. It's a traditional method. Whereas for methane and all, we have gone for the emission techniques using GCMS. And then some process-based models are also available that we try to compare with the field observation data and validate that. So this is one of the study under NRC National Hydrology Project. It is done for tea as well as the vegetables. So here in this particular project, what we have done is that NRC project I am not discussing in detail, but this one is what we tried with Kerala. Three objectives were there, mainly to understand the carbon stock and different fractions of carbon pools, and what is the potential of each zone based on the land use, as well as the carbon dynamics or GHG emissions, how it is there, or what is the changes happening. So here we have identified 5 districts in Kerala and did the analysis based on these criteria. Farms were selected based on these 6 criteria: agroecological units, AAU, then cropping system, irrigated as well as rainfed, topography based, because Kerala, as many of you know, it is divided into 3 zones: lowland, midland, highlands. Less than 7.5 meters, 7.5 to 75, and above 75 meter elevation. Then size groups: marginal, small, medium, and large. Then the 6th one is organic and inorganic, wherever that option is available. Because Kerala being now focusing on organic, we got a lot of plots. So this is the selected areas, land use cropping systems, as well as the important crops which we have selected: paddy, coconut, banana, arecanut based, rubber, nutmeg, pulses, fruits and vegetables, forest area, as well as which are all the zones and all. This is some sample data, how we have collected all those things, including livestock, and few field experiments also to monitor this carbon dioxide emission as well as sequestration potential, and then modeling different crops with the different management strategies. All those things have been attempted. And the emission, as I mentioned, we have compared with the instrument as well as the traditional method, because wherever the instrument it is not possible, we have gone with the alkali crop method. And the changes we have observed, the main findings what we observed is the maximum yield was in the under the open condition, it was with the organic manuring, whereas in the polyhouse or controlled condition, it was the integrated nutrient management found to be a higher yield. Whereas the yield decline was noticed under polyhouse conditions. Means polyhouse in the sense here what we mean is elevated temperature. So 20.5% or 20.4% yield decline was noticed. But that also, if you can go with the combination of organic, inorganic, as well as mulching, we could found that the yield reduction can be minimized or it can be reduced. So which means that under adverse climatic conditions or extreme conditions, if the nutrient management or water management practices are followed, you will be able to sustain the crop. This is what our findings showed, that enough mitigation strategies along with the adaptation strategies need to be adopted for sustaining the crop production under changing climatic scenario. Similarly, for mulching also, we have done few field experiments. That results also, these are all two. One is published in Current Science and another one is International Journal of Plant Production. You can verify, means see those papers, field studies with the vegetables and perennials on carbon emission and how the water and nutrient management strategies we can adopt under especially the elevated temperature. So here also we found that black pepper, the emission was higher because of the root activity. And another thing is it is being grown with the support crop. So there will be two crops. So that may be one of the reasons for the higher emission and higher microbial activity. This is what I was saying. And among the three crops, the major was from the black pepper, and mulching as a management practices enhance the carbon sequestration potential on a long-term basis. Similarly, soil temperature is also influencing the decomposition or your GHG emission pattern. Similarly, as I mentioned in the beginning, under precision farming or micro irrigation, also we have measured the carbon emissions and found that the net emission is less in the case of micro irrigation. That is because the total productivity is higher and water productivity is less, so that water footprint will be less and energy savings is also there. Electricity emission means through emission through electricity is also less. So all this contribute together to make the net emission less compared to the compared to the conventional method. Another thing is that under sugarcane we can go for the shredding of trash, which will improve the soil organic carbon one way. Another way, it results in the higher productivity and improvement in the soil health, as well as it is reducing the soil GHG emissions. So these are all few of the technologies which we are having. Maybe 5 minutes I will take here and then I may be stopping. So if someone of you is interested, you can be in touch with us. Nutrient budgeting. This is one software which we have obtained the copyright. It is an integrated crop nutrient management software, which will help you to derive the nutrient recommendations if you provide the database like which is the soil there, soil samples or soil type, or if you have some database. Then another one is low cost soil moisture sensor based automatic irrigation system. This actually we have filed for the patent, which is to be get, and then magnetic treatment of low quality irrigation water for improving the water and crop productivity. Then low cost domestic wastewater treatment system. which I have not presented here, but if someone is interested, I can share those means what we have done also, I can tell. Then drip fertigation techniques and irrigation and fertigation scheduling we have derived for most of the crops in Kerala as well as Tamil Nadu. Then drought assessment and management system, this is also copyright we have obtained. Then coconut irrigation advisory system, crop water requirement. Then DSS on soil erosion, copyright obtained. And carbon calculator. Soil erosion, I think I will show some of the slides. Similarly, integrated crop nutrient management also, I will show some of the slides, how it is being done. So with respect to nutrient management or nutrient budgeting, this is the software we were using, Netmon and model. This is a very old study, like 2007, 2010, like that. So this is also calibrated and validated for different sets of conditions. So this will give you a picture like this way. How it is going, means within the farm, how the nutrient is flowing from one field to another field also we can understand. The thickness of the line indicates the quantity of the nutrient flowing, whereas the thin line indicates very less nutrients are flowing. So a farmer or a agricultural officer can understand actually the nutrients, where it is moving from, whether it is going externally from field to outside or coming inside, all those things he can understand. So it will help you to devise the policies or strategies. So based on that, we have derived the recommendations, NPK, like that. Each one you can derive. So this is the software. It is available in the site also. You can very well verify. So here, what you need to provide the information is some basic details about the farmer and the location. If it is within Kerala and Tamil Nadu, we can give the locations, and then the background database will fetch the soil data. But suppose if for some other location you want to understand, then you need to have the soil test data or soil data you should have. So rainfall and all already inbuilt, it is there, so it will be showing. If you want to change also, we can alter. Then crop, which is the crop the farmer is going to choose, that has to be there. But at the same time, you have to give the basic details like previous crop, what it was. So all those information also you need to give. So it is little bit cumbersome process, but still for the agriculture officers and all, it will be really helpful, and people are using it also. So this is what the soil health card, finally it will come in the local language as well as the in English. And initially, what is the status also it will give, whether the nutrient balance is positive or negative. So based on that, for the new crops, it will be adjusting how much quantity of nutrient you have to apply. So this is like the irrigation water requirement I was showing for coconut, black pepper, for each zones. This is also one of the softwares. This is what I was telling about the low cost soil moisture sensor based automatic irrigation system. It can be given for greenhouses, polyhouses, or even open fields, and you can operate through mobile. And few like hydroponics and advanced techniques also we have attempted under changing scenario, what will be happening to the urban agriculture and all. So then coming to the soil erosion DSS, this is what we have developed. So here we have done for Kerala. We have the database or the thematic layers of geology, soil, land use, land cover, geomorphology, and then based on satellite data, we computed the from the DEM as well as the other database, we computed the stream order as well as the erosion factors, RKLSCP, and then delineated that. After that, what actions you have to do, like whether you have to do which type of watershed management also, we have come out with that. So soil erosion will be quantified, then prioritization of micro watersheds based on the land use, then soil terrain characteristics, we will be suggesting the suitable structures. So this is actually initially for validation. This paper also recently published. We used different models, and based on that we computed that, and the same has been evaluated in the field also using multi-slot devices, and then calibrated and validated the models. And this is the final DSS support. This is also available in our website. We can check it. Soil erosion risk decision support system. So initially you have to select the district, then your taluk, and then your panchayat. So automatically the map will be displayed like this. Which area is slight erosion, which area is moderate erosion, which is extremely severe erosion, like that. And those details you can take it based on the panchayat. This is for 2 districts like Malappuram and Kannur. So after that, if suppose a soil conservation officer want to know about his areas, where the structures can be built or what are all the management strategies they can adopt, it will be suggesting. But it may not be that much accurate because that we have not validated. Up to erosion, we have validated. So here, automatically, it will take into Google Earth and show where these structures can be built. For example, contour bunds or your check dams. Like that, those information it will be giving like this in the Google Earth, and the farmer can, means the soil and water conservation officer can very well verify the same. So in a nutshell, these are all the techniques or adaptation options. These are all known things only, but many of the things we have validated at the field level. And so directly, if it is found to be suitable, we can go for adopting such techniques, and holistically that will try to improve your crop. So one is water saving technology, because most of our studies concentrated on soil and means soil nutrient as well as the water management. So one is this one, then integrated farming systems, organic farming and conservation agriculture, agro-horticulture and agroforestry, especially the mixed cropping systems. Then the choose of means insurance. This is what we tried in that pilot project which I was telling about, the paddy yield forecasting. So that during the cropping season itself, you can forecast the yield. So if there is an extreme event happening, we can very well identify which area it is affected, so that the farmers can get the crop insurance. So it has a multiple usage, not only yield management, but at the same time, if there are climate extreme events and the crop is getting affected, that can be verified very well with that particular methodology. So these are all the techniques or technologies which is available with us. If someone is interested, you please contact us. We will be ready to support. And so here I would like to thank all my colleagues, research scholars, as well as our fellow scientists. And the funding support was mainly from Department of Science and Technology, Kerala State Council, DFAC, Ministry of Water Resources, Environment, Climate Change, etc. And with this, I'll be stopping. Maybe another 10 minutes. I think I stick on to the time. Maybe it was very fast, but just I want to showcase all the things whatever available with our results. And if someone is interested,
thank you so much. Participants, if you have any questions, please ask it, sir. Please ask your questions.
Am I audible?
yeah.
Yes, yes.
Yeah, sir. As you said, water saving technologies. Can we adopt alternate wetting drying technology thoroughly in rice? If so, what will be the prospectus of nutrient